Now, calculating Ks is where you can possibly run into some problems. Calculating the solubility is much easier. The only way you're going to be asked to calculate solubility is if you are given the Ks value. Okay, you must be given this, and if that's the case, you just have to decide whether you're going to be taking the square root or dividing by 4 and doing the cube root calculation. Now, I'm calculating Ks. Okay, if you're asked to calculate Ks, if it's a 1 to 2 ratio like this, you're going to be using Ks equals 4s cubed. So you have to know the solubility. If it's a 1 to 1 ratio like this, you have to know the solubility to work out Ks. Now, they can just give you an S value, the solubility in both cases, in which case it's reasonably straightforward. But there are other ways of doing it. And the first is they could give you, for instance, the concentration of the carbonate ion. Now, they could say that the concentration of the carbonate ion in solution of 1.15 times 10 to the negative 4 moles per litre. So if they told you that the carbon ion concentration was this, and that would usually be qualified by saying in a saturated solution. Now, as soon as they say it's a saturated solution, they're telling you that it's at equilibrium, and that's what you're calculating. Now, if they'd given you the concentration of the silver ions in solution, that would have been a different calculation, because remember, that's 2s, and the carbonate ion concentration is the same as S. So, for instance, this would have been something like 2.3 times 10 to the negative 4. If you had been given the silver ion concentration, you would have to divide it in half, because it's equivalent of 2s, to find out what S is. Okay, so the second way they can question this is to give you solubility in a different way. They can tell you the concentration of either of these species, and you just have to have awareness, is that concentration the same as S? And if there's only one of them, it will be, and if there's two of them, it's going to be half that concentration. Now on this side it's a little bit easier. If you're told, for instance, that the concentration of the sulfate ion is going to be equal to 2.51 times 10 to the negative 9. So I'll just move that so you can see that better. 2.51 times 10 to the negative 9 moles per litre. Well, and that's in a saturated solution. The concentration of that sulfide ion will be the same as the concentration of the Fe2 plus ion, and all you've got to do now is square that concentration, because it is the same as S. So that's a second way that can be done. Oh, and just so you know, the Ks values here I've just calculated. Remember, Ks values have no units. Alright? And now for the third way that this could be asked. Okay, now this is a slightly sneaky way. Maybe you're being asked to find the Ks for magnesium hydroxide. So you're thinking to yourself, well, I know I've got to use 4s cubed because it's a 1 to 2 ion situation. So I need to find S, which is a solubility. Now they haven't given me the solubility, so if they've given me the concentration of this, I could work it out. Or even if they gave me the concentration of this, I could work it out. I'd have to divide it in half, because it's going to be double what S is. But instead, they've done it this way, where they've said 0.48 grams of magnesium hydroxide solid is obtained from evaporating a 50 ml saturated solution. Now, this is another way of just giving you the solubility. So, you need to use a formula, moles divided by volume. You need to know that. Now, how do you work out the concentration? Well, you work out the moles first, which is going to be equal to the mass divided by the molar mass, which is 0.48 grams divided by 58.3. Now they'll always give you the molar mass, okay? So that's 0.48 divided by 58.3, and that equals 8.23 times 10 to the negative 3 moles. So I'll just put that up there. Then you're going to divide through by the volume. Now the volume must be in litres, it's in mils at the moment, so it's going to be 0.05. Okay, so 8.23 exponent negative 3 divided by 0.05, and that equals 0.1646 moles per litre. Now, if I then cube that, and then times it by 4, that gives me a final answer that Ks equals 0.0178. Just one last thing in regards to pH. A lot of the solids we're talking about involve hydroxide, like calcium hydroxide or magnesium hydroxide is a previous one. So obviously there's going to be a hydroxide ion concentration. Now, just so you have an awareness, you can work out that hydroxide ion concentration if you're given the pH. They say it's a saturated solution of calcium hydroxide and it's a pH of 9.5. Then you can convert that pH into a hydroxide ion concentration. And now that you know the hydroxide ion concentration, you could in fact work out the Ks. However, whatever that hydroxide ion concentration ends up being, remember in this case it would be equal to 2s. So you'd have to divide it in half and then go for s cubed. Okay?